Let's try to solve another Leetcode problem. 1634. Add two polynomials represented as linked lists. So this problem is similar to merge two linked lists. Let's just first set an example to understand what it looks like. I think from here, let's just check this example. So this is just one of the representations. So for example, it is 5 times x to the power of 3 plus 4x and minus 7. So this is the coefficient, it's going to be 5 and power is going to be 3. So this means it's going to be 5 times x to the power of 3. And for the next, we're going to plus the coefficient 4 and x. And for the last, it's going to be minus because the coefficient is minus 7. Basically, it is a plus minus 7. So we're going to turn it to minus 7 because the power is 0. And finally, so this node going to point it to none. So we just need to calculate a plus. So for example, let's just use the first example. So for the first example, because poly 1 is x and poly 2 is 1, so after that it's going to be x plus 1. So the representation is going to be a linked list. But here we don't have the linked list node, it's going to be a poly node. We just need to merge two linked lists, but we're going to use this poly node to represent the linked list. Now let's just start coding. I think everything should be quite clear about the problem. So for such problem, normally I'm going to prepare the dummy node because this is going to be easier for my coding. And for the node, I'm going to prepare the poly node. And I will prepare every empty poly node. So this means x equal to 0 and y equal to 0 and next going to equal to none. So this is going to be an empty poly node. Now I can start the while loop. So while poly 1 and poly 2. So first of all, I'm going to check the power because according to the representation, if the power is bigger, normally this is going to be the first. For example, this x to the power of 3, so this is going to be at the first position because this power is bigger, it is 3, and the second is going to be 1. Because this is just the rules of how we can represent everything. So now, and we're going to check the power. If poly 1 dot power is more than poly 2 dot power, so this means we're going to update the p, going to equal to, we're going to update the p dot next first. So p dot next going to equal to a poly node. And inside, as poly 1's power is bigger, so we're going to take the power on poly 1. So first of all, it's going to be the coefficient, and then we're going to take the power. So after that, we're going to update the pointer p, it's going to equal to p dot next. And then we're going to update poly 1, going to equal to poly 1 dot next. So this is going to be the first step. So the second step is that we just need to copy the code, and we're going to change it to poly 2. So now, if poly 1's power is less than poly 2 dot power, so p dot next, we're going to change it to poly 2 from here. And here we're going to change it to poly 2. Now let's just check the third case. So this means the poly 1 dot power going to be equal to poly 2 dot power. So if the power equal, we just need to check the coefficient. So we're going to check poly 1 dot coefficient plus poly 2 dot coefficient. So if the sum of them equal to some value, definitely not equal to 0. So this means we're going to update the p, so p gonna equal to we're gonna update the p dot next first, so it's gonna be a poly node, and inside it's gonna be the coefficient, it's gonna be this one, poly 1 dot coefficient plus poly 2 dot coefficient, and the power as they are equal, so we can choose poly 1 or poly 2, it doesn't matter because they are equal. And after that we're gonna update the p pointer, it's gonna equal to p dot next. So no matter if they are equal or not, I mean, no matter poly 1's coefficient plus poly 2's coefficient equal to 0 or not, definitely we're going to update poly 1 or poly 2. So we're going to update it from here. So poly 1 going to equal to poly 1 dot next, and poly 2 going to equal to poly 2 dot next. Let me just copy some code. So here it's going to be poly 2. Now I think it is everything, but we don't know at the end while we go out of the while loop if there's still something inside poly 1 or poly 2, we don't know, but we're going to update it from here. So at the end, we're going to update the p.next. It can be poly1, or it can be poly2, or it can be none. It doesn't matter. So finally, we just need to return dummy.next. So this is exactly the same like merge two linked list problem. This is just use some other ideas, polynomials. Actually, it is the same. Now let me just run it to have a check. As you can see, it works. Now let me just submit it to prove it should pass. As you can see, it passed. And the time complexity is O(n) because this is the merge two linked list problem. And thank you for watching. See you next time.